All right, so for this next problem, we have this square that was changed size into a rectangle, and one side was increased by 1 centimeter, so that's where this +1 comes from, and the adjacent one was decreased by 1 centimeter, so that's why it's a -1. And remember, on a square, all the sides are equal, so they would have all been x, so we have the x + 1 here and the x - 1 there. And the area of the resulting rectangle is 48. So this is the resulting rectangle, and its area is 48. So remember that area is equal to length times width. Thank you. And that is going to be length times width right here. So we're going to, part A just says to set up your function. So x + 1 times x - 1 equals area, which is 48. And then B says to determine the length of the sides of the original square. So the original square was x, so we're just trying to solve for x here. So here's my answer to A. Now to get to B, I'm just going to start working this out. I'm going to FOIL, so the first terms, the outside terms, x times -1 is -x. The inside, +1 times x, positive x, and the last is +1, -1, -1. And maybe you notice that this is the difference of two squares, just backwards, because these middle terms drop out, they cancel, and I'm left with x squared - 1 equals 48. And so then this is just our square root property. So we're going to add 1 to both sides. That gives me x squared equals 49. Now square root both sides, and x equals positive or -7. So remember, that's two different answers. And we can disregard -7 because this square isn't going to have a length measure that's a negative number. So it's just 7. So x equals 7, and be sure to put your units as 7 centimeters. Oh, actually, that's for part B. 7 centimeters. Now, this is not part of the problem, but just as a heads up, if the problem said to find the lengths of the sides of the new shape, the rectangle, you would take that 7 and plug it in here and get 8, and plug it in here and get 6. And you would say that it's 8 centimeters for one side and 6 centimeters for the other. So just be aware of that kind of a difference. And then for this last problem, if you haven't read it already, pause the video, take a minute, read the problem, annotate the problem, find the important information, and then come back to the video after you've thought it through for a minute. Now, there are some differences in this problem than the projectile problems that we did in class. So for example, the problems that we did in class, the formula was set up like this. And in this problem, our formula is set up like this. So here are some similarities and differences. Similarity is that they're both height equals the formula. And this one is height equals the formula. One difference is that in this formula, it's just written h, and in this formula, it's written h of t. This is called function notation. We've worked with this before. It's just saying that height depends on time. It's not h times t. It's just different ways of writing this idea that height depends on time. So height is a function of t. So some similar things in the formula. They both have t squared with a negative number in front. They both have a t with a number in front. Now, the situations were different, so those constants, the -16, the -5, they're slightly different. In the problems we did the other day, we plugged in the velocity for v sub 0, but here the velocity is already there, 30. Now, the main difference is that this has a constant at the end where the equations we worked with before don't. And what's happening is this. The rocket is launched from a building that's 10 feet high. So before it's even launched, it is already 10 feet in the air. So you'll notice in the problem it says that h is the height of the rocket above the ground. Well, the ground is down here. So the rocket is going to be launched. Now, when the time is 0, when t is 0, right, it hasn't gone anywhere. So it's already at 10. So imagine for a second that you put 0 in for these t's. They would drop out, right? And you'd be left with just that 10. So at time 0, the height is already 10. But the problem is asking me how many seconds before the rocket's height is even with the roof of the building again. So it starts on the roof and then it goes here, and here is where it is even with the roof again. So it's asking me what is the time that it takes to go from here to here. So I know I need to solve for t. That's my unknown. So I'm going to leave it t. But I need some kind of number on this side so that I can start solving. What am I going to put in for the height? Well, what is the height here? So, and the height there is not 10, but 0. The 10 is already part of the formula, so I don't have to plug that back in. Think about it right here as being 0. At time 0, the height is 0. And then, so how long does it take to get back to a height of 0, right? It's like air quote 0, like consider the roof at 0. So then we're just going to put 0 in there, and then we're going to do math to solve. On the PDF, the PDF that's in your Google Classroom, I divided everything here by -5. That's not necessary. That's because I wanted to see if I could factor, and dividing by -5 makes my first factor, my first coefficient 1. And I noticed that everything happened to be divisible by 5, so it was convenient. Now, when I go to try to factor what multiplies to -2 and adds to -6, what I discovered is I can't factor it, so I have to go to quadratic formula anyway. All right, so now let's say you automatically looked at the equation here first before I divided by -5, and right there you said, you know what, I'm going to do quadratic formula. You're going to get the same answer as me, but our numbers are going to look a little bit different first because I divided by -5. Okay, so I'm going to go ahead with quadratic formula here. A is 1, B is -6, C is -2. So that's negative B plus or minus the square root of B squared minus 4AC all over 2A. So I'm going to do this -6 and make it positive. In the denominator, 2 times 1 is 2. And then I have plus or minus whatever number goes in the square root. So I'm going to do my square root math just right on top of my radical right here. -6 squared is a positive 36. Then the multiplication, -4 times 1 is -4. Bring down the -2. That's multiplied is positive 8. When I add that to the 36, I get 44. So now I'm at 6 plus or minus square root of 44 over 2. I'm going to use a calculator to convert this to convert this radical to a decimal, and I think that is 6.6. So 6 plus or minus 6.6 over 2. Now that's two different answers. That's the positive version of 6.6 and the negative version. I can disregard this version because I have 6 and I'm subtracting more than 6, right? 6.6 is greater, so that's going to be negative. I don't care about negative. So this is going to be 12.6 divided by 2, which is 6.3, and my units are seconds.